On my English test paper once, I do more than I wrote. But I didn't.
Okay. Signs of derivative and second derivative. This is very
you
important.
had started doing this with
Yeah.
me.
Now, what is important in this you need to realize is, if you have a graph, if this is point A, this is point B, this is point C, this is point D. Where is the function increasing? Just looking at the shape of the graph. A to B and C to D. And where is the function decreasing?
B to C.
The decreasing from B to C. Correct? You always go from left to right. Now in derivative sense, when your function is increasing, your first order derivative will be positive.
Okay.
So when you take the first order derivative for an increasing function, the first order derivative will be positive.
Yeah.
So you find out the derivative and you take in any value between A and B, any x value and put it, you will get a positive value. And obviously when the function is decreasing, what will happen? The derivative would be negative. So you have to learn this up. These are the condition for an increasing function.
Zero.
Derivative is positive.
That's when it's a constant and it's a
and this is negative. Acha, what happens when the derivative is 0?
That means it's a straight line. Like y is equal to 4.
It's a horizontal line.
So it's a constant on the derivative.
So it's either a local maximum, local max, or it can be a local min when the derivative is 0. Means your tangent is horizontal. Your tangent will have a positive slope. See, here between A and B, your tangent is having positive slope. Yeah. Your tangent is having positive slope. Between B and C, your tangent. So remember, derivative slope of the tangent. Your tangent is having negative slope. Yeah. Your tangent is having negative slope. And at this point, the slope is 0. Yeah. One more condition exists when the slope is 0. That's your horizontal point of inflection. Like your x cube ka graph. Yeah. So here also, for the horizontal point of inflection also, your first order derivative is 0. Yeah. So in the first order derivative is 0, there are three things. So if your first order derivative is 0, either can be local maximum, it can be a local minimum, or it can be a horizontal point of inflection. Correct?
Yeah. So basically any time where it's touching only once, or unless it's like this y is equal to 4.
First order derivative has to do with increasing and decreasing. Now, looking at the shape, I just copied the shape again over here. Looking at the shape, this, when you have like this, it's basically concave down. When you have this is concave down and this is concave up. Correct?
Yeah.
So when you have concave down,
so we did all this.
So when it's concave down, your second order derivative would be negative. This concave down. And when it's concave up, your second order derivative is positive. It's concave up. So let's summarize. 1. Local max. How do you get the local max? What are the steps? You will take the first order derivative equal to 0. First order derivative 0 for local max. Local max first order derivative 0. And when you look at the sign diagram for a derivative, it will be first be concave up, then concave down. It will be increasing and then decreasing. For this, or your first order derivative is 0 and your second order derivative is negative. So remember, there are two tests for local maximum. 1a is the first order derivative 0 and the sign change positive negative. B is the second order derivative test. The first order is 0 and second order derivative is negative. What do you mean by negative? Concave down. Now concave down will have a maximum.
And concave up will have a minimum.
Minimum. Okay, so how do you find local minimum? How will you do it algebraically?
First derivative equals 0.
You solve it, draw a sign diagram, and then what do you do? What is the sign diagram? No, what is the sign diagram?
Oh,
Negative, positive.
and then up to
Or what will you do? First order derivative 0
and second order is greater than 0.
and second order derivative will be what?
Greater.
Greater than 0. Concave up. Okay. Third, what will happen for point of inflection?
Same.
Now point of inflection is something different. Remember, for a point of inflection,
It will be the same before.
the three steps. Listen. First step, you solve second order derivative equal to 0. Remember, for point of inflection, the second order derivative is 0. And there should be a sign change for the second order derivative. For the second order derivative, there should be a sign change. Means if you draw a sign diagram, the second order derivative should be positive, negative, or it should be what? Second order derivative, sign diagram. Negative, positive. And then you put in the first order derivative. And if it's equal to 0, then it's a horizontal point of inflection. And if it's not equal to 0, first order derivative at point B is not equal to 0, then that's an oblique point of inflection. Now this we'll be doing later, but I'm just doing this for completion of this part. But this is the main thing you need to remember in this chapter.